Hi guys, this is AS Chemistry, Organic Chemistry, and we are looking at carbonyl compound. Question 19. A hydrocarbon P with the formula C6H12 readily decolorizes bromine. On reaction with hot concentrated acidified potassium manganate 7 solution, a single organic product Q is obtained. Q gives an orange precipitate when reacted with 2,4-dinitrophenyl hydrazine 2,4-DNPH reagent, but has no reaction with Tollens reagent. Explain these observations. So, if it decolorizes bromine, that means P has a double bond present. In other words, it is an alkene. So, this is what we can get from the first observation. Next, on reaction with hot concentrated acidified potassium manganate 7 solution, a single organic product Q is obtained. So this can be predicted as Q is a single organic product made from a symmetrical alkene. So if the alkene is symmetrical, then we will have the same product being formed after the double bond is broken. So a same or a single organic product. There is another possibility as well. Or a terminal CH2 next to the double bond is present, which is oxidized to CO2 and H2O. So the other organic product is the only one that remains and is Q. And Q gives an orange precipitate when reacted with 2,4-dinitrophenyl hydrazine, but has no reaction with Tollens reagent. Q is a carbonyl compound which is a ketone due to no reaction with Tollens reagent. If it were an aldehyde, it would have reacted with Tollens reagent. It is giving a positive result with 2,4-DNPH, making it a carbonyl compound, and it not reacting with Tollens reagent confirms it to be a ketone rather than an aldehyde. Draw the skeletal formula of P and give its name. So the molecular formula is C6H12. And since we are going to make a symmetrical alkene, so if we have a double bond present between two carbon atoms, then each carbon atom must have a CH3 group attached to it. That would give us the molecular formula of C6H12. And in order to convert this into a skeletal structure, we would make it this way. This is the skeletal structure of the given compound, and the name of this compound would be 2,3 dimethyl butene, and in this way we would end up with only one organic product when this particular alkene is oxidized. Draw the skeletal formula of Q and give its name. So Q would be C double bond O bonded to two CH3 groups, which would be the same compound formed when the double bond breaks. And the skeletal formula of this would be this. A double bond O with the central carbon atom and two CH3 groups at each terminal. So the name of this compound would be propane 2-one. Question 20. P, Q, and R are structural isomers with the molecular formula C4H8. All three compounds readily decolorize bromine in the dark. P and Q do not exhibit stereoisomerism, but R exists as a pair of geometrical cis-trans isomers. All three compounds react with hot concentrated acidified potassium manganate 7 to produce a variety of products as shown in the table. So, product with PR, carbon dioxide, and C3H6O. So, this has to be a ketone. And Q is carbon dioxide and CH3, CH2, COOH. So this has to be an aldehyde with respect to the carboxylic acid. And CH3, COOH only means it's a symmetrical alkene with two carbon atoms on each side of the double bond. So S reacts with 2,4-dimethyl phenyl hydrazine 2,4-DNPH to form an orange crystalline product, but does not react with Felling's reagent. So S is a ketone. Give the structural formula of PQRNS. So P would be a carbon atom with two hydrogen atoms on it, forming a double bond with a carbon atom with two CH3 groups on it. This would be the structure of P. So condensing this structure, we would have CH2 double bond C CH3 twice, because these are the bonds that we could derive from the products that are found. The CO2 represents the structure being uh, being an alkene having a terminal carbon which forms the CO2 group, and the rest of it forms a ketone with three carbon atoms. So C double bond O would be the central carbon atom. So this is the structure of P. Next, let's look at Q. Q is CO2, so there is a terminal carbon again. So a double bond from the first carbon atom to the second carbon atom, and then we have CH3, CH2, COOH. So this would be the carbon atom with the COOH part. So this would be CH bonded to CH2 bonded to CH3. So this is the structure of Q. So the condensed formula would be CH2 double bond CH, CH2 and CH3. Next we have R. R is CH3 COOH only. So this would be a central double bond between two carbon atoms, and each carbon atom having a CH3 group attached to it. So this would be CH, CH, and then we would have CH3 on either side. So the formula of R is CH3, CH double bond CH, CH3. And as far as S is concerned, S is the ketone that forms. So that is C double bond O with a CH3 group on both sides of the C double bond O group. So this would be CH3, CO, CH3. So these are the four structures P, Q, R, and S based on the information given in the question. Explain what is meant by the term stereoisomerism. So this refers to different molecules having the same molecular and structural formulae, but different displayed formula, which can also be written as different arrangements of atoms in space. So this is the complete definition of stereoisomerism. Draw the displayed formula of the geometric isomers of R and name them both. So R has a carbon atom, in fact two carbon atoms with a double bond between them having two hydrogen atoms, one on each carbon atom, and two CH3 groups, one on each carbon atom. So if they're on the same side, it would be called cis bute 2-ene, and if they're on the opposite sides, the hydrogen and the CH3 groups are present on opposite sides of the double bond on the two carbon atoms with the double bond between them. This would be known as trans bute 2-ene. State a reagent that could be used for the reduction of S and name the organic product of this reduction. So S is a ketone. S can be reduced using a mild and a harsh reducing agent both. So let's go with the mild one. It would be NaBH4 plus water, which would be able to carry out the reduction of compound S, and the name of the organic product that this would form would be a secondary alcohol having three carbon atoms with the OH group on the second carbon atom. So it would be called propane 2 all. Question 21. Ethanol reacts with hydrogen cyanide in the presence of a small amount of NaCN as shown. Complete the diagram to show the mechanism of this reaction. Include all necessary charges, partial charges, lone pairs, and curly arrows, and show the structure of the intermediate. So here we have a Cn negative ion which is from NaCN, which starts off the reaction. So this is the lone pair of electrons on the carbon atom in NaCN. This is the partial positive charge on the carbonyl carbon atom and the partial negative charge on the oxygen attached to the carbonyl carbon atom. So the lone pair of electrons on the Cn ion would be attracted towards the positively charged carbonyl carbon, which would result in the breakage of the CO pi bond. This would give rise to an intermediate in which we have a C triple bond N group attached to the carbonyl carbon, which is attached to hydrogen on one end, a CH3 on another end, and an oxygen ion on the third end, having a lone pair of electrons. Now we have HCN present along with this intermediate. So HCN has a partial positive charge on the nitrile carbon, rather the H positive ion, H positive, no, not H positive, H having a partial positive charge on the hydrogen part of this molecule and a partial negative charge on the CN part of this molecule. So this bond would undergo heterolytic fission because of the attraction of the lone pair of electrons on oxygen for the positively charged H positive ion. So this breaks the HCN bond. The H adds onto the oxygen atom forming the OH group, and the product is shown having the OH group completely formed, and we have a box in which we would place the Cn negative ion. This is the Cn negative ion that was released when the H and C bond underwent heterolytic fission in the molecule HCN. So we started the reaction off with was Cn negative ion, and we ended the reaction with the Cn negative ion. So a Cn negative ion in this reaction is acting as a catalyst. With reference to your mechanism in one, explain the role of the NaCN in this reaction. Like we just stated, it is acting as a catalyst. So the reaction starts off with the Cn negative ion of NaCN and a Cn negative ion is regenerated at the end, making it a catalyst for this reaction. Question 22. There are 7 structural isomers with the molecular formula C5H10O that are carbonyl compounds. 4 of these are aldehydes. These 4 aldehydes A, B, C, and D have the following properties. Aldehyde A has a straight chain while B, C, and D are branched. Aldehyde B is the only one of the 4 isomers with a chiral center, and it exists as a pair of optical isomers. Aldehyde C has 2 methyl groups in its structure, but D has 3. Give the structure of these 4 isomers. So we have C5H10O, and A being a straight chain aldehyde, we would have CH3, CH2, 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 and CHO as the structure of A. B has a chiral carbon atom present, so we would have a carbon with a CHO group on one end, a hydrogen on the other. On the third side, it would have a CH3 group, and on the fourth side, it would have a CH2 and a CH3 group, making this carbon atom a chiral carbon atom. Next, we have structure C, in which there are 2 methyl groups present. So we would have a carbon atom having 2 methyl groups on it, CH3 and CH3. Then we would have a CH2 group, and then we would have a CHO group. This would be structure C. And as for structure D, it has 3 methyl groups. So a central carbon surrounded by 3 methyl groups would have an aldehyde group on its fourth position. This gives us the 4 structures A, B, C, and D of aldehydes, which are isomers of each other, having a molecular formula C5H10O. Draw the 3-dimensional structures of the 2 optical isomers of B. So B has a central carbon atom having a hydrogen atom on one position, a CHO group on another position, a methyl group bonded to the chiral carbon atom on the third position, and on the fourth position it has a CH2 and a CH3 group bonded, making it a chiral carbon atom, and because of which it has the 2 optical isomers as shown. Describe a chemical test that would allow you to distinguish between any of the 4 isomers A to D and any of the other 3 structural isomers C5H10O that are carbonyl compounds. So that means the other 3 isomers would be ketones. In your answer, you should describe any necessary reagents and conditions as well as explaining what you would see in each case. So in order to test for aldehydes, we could use Tollens reagent. So adding Tollens reagent and warming results in the formation of a silver mirror or appearance of a black precipitate, which is a positive result for aldehydes. So this is just one of the tests that can be performed. There are several other tests which include the Fellings test, which includes oxidation. Now, oxidation can use either KMnO4 acidified, in which we would see the color change from purple to colorless, or we can use uh, potassium dichromate acidified, and the color change would be orange to green. So, oxidation has 2 possibilities. using acidified KMNO4, or we can use acidified K2Cr2O7, and the color change for KMNO4 is purple to colorless, and for K2Cr2O7 it is orange to green. So there are three separate tests that can be performed to identify the aldehydes and distinguish them from the ketones having the same molecular formula C5H10O. Describe a test that would give the same result with all seven carbonyl isomers C5H10O. So that would mean the detection of the carbonyl group. So we would add 2,4-dinitrophenyl hydrazine, which is also known as Brady's reagent, and the observation would be appearance of a yellow orange precipitate. Question 23. A, B, C, D, E, and F are all structural isomers with the molecular formula C4H8O. A, B, and C all give an orange precipitate when treated with 2,4-D and pH, but only A and B give a brick red precipitate when warmed with Fehling solution. So A and B are aldehydes while C is a ketone. So we need to draw the Scadal formula of A, B, and C. So A could be a straight chain aldehyde having four carbon atoms. So these are four carbon atoms. The fourth carbon atom would be attached to a double bond O group, making this an aldehyde. And we can have a three carbon aldehyde with one of the carbon atoms having a CH3 group attached to it as a substitute group. And the third one has to be a ketone. So we can have four carbon atoms in a straight chain with the second carbon atom having a double bond O present on it, making it a ketone. And in order to name this compound, the compound drawn in A would be butanol. The compound drawn in B would be 2-methyl propanol, and the compound drawn in C would be butane 2-one. Name the type of structural isomerism shown by A and B. So in A, we have a straight chain compound. In B, we have introduction of branching, and branching is a form of structural isomerism called chain isomerism. So A and B are chain isomers of one another. State what you would see when a sample of A is warmed with Tollens reagent. So A is butanol, it is an aldehyde. So when warmed with Tollens reagent, we would observe the formation of a silver mirror or the appearance of a black precipitate. Either of the two results is a positive observation for the presence of aldehydes. Another compound G, C3H6O, contains the same functional group as A, so it is an aldehyde. Give equations for the reactions of G with each of acidified potassium dichromate 6 and sodium tetrahydroborate NaBH4 using square bracket O and square bracket H as appropriate. So, with the reaction with acidified potassium dichromate, it is an oxidation reaction. So, C3H6O will oxidize to form C3H6O2, which is propanoic acid. So C3H6O2. This would form propanoic acid because it is an aldehyde. And with NaBH4, the reaction would be reduction. So we would include square bracket H as a reactant, and C3H6O would be reduced to C3H8O because we would have addition of two hydrogen atoms, because the C double bond O will convert into CH2OH. So this would be converted into C3H8O. And in order to understand what is being formed, C3H6O2 is CH3, CH2, C double OH, and C3H8O is CH3, CH2, CH2OH. So a carboxylic acid is formed upon oxidation of C3H6O aldehyde, and primary alcohol is formed upon reduction of C3H6O aldehyde.